Now let's move towards pressure. We all know that the tires of two-wheelers or the four-wheelers gets pressurized, and then we need to fill the pressure into it. The air pressure is filled into it with the help of air filling machine, and it has an indicating dial or a digital meter to show the digital reading of pressure. So the machine fills the pressure to a limited value and not over it. And we are also aware of the fact that a force has to be applied for filling the air in the bicycle tire with a hand pump, or otherwise foot pumps are also available, but in both the cases pressure is to be applied, then and then only the air will be filled into the tires. So by applying force, air pressure is increased and then the air is pushed into the tire. So one question is asked over here, whether force and pressure are related. Yes, force and pressure are surely related, and pressure is the ratio of force and area. So if greater the force, greater is going to be the pressure, because force and pressure are directly proportional to each other. So if the force is greater, pressure is going to be greater. Force is lesser, pressure is going to be lesser. But force and area are inversely proportional to each other, because if area is less, then the pressure is going to be more. So for higher pressure you will require higher force with lesser area, and for lesser pressure you will require force with higher area, or the surface area should be more. So this is the relation between force and pressure, and for pressure and area. Now there is one activity given, that if you are taking a sharp pointed nail and you try to push it into the wooden plank by hammering on its head, then the nail will be easily penetrated into the wooden plank, because its pointed end will be easily penetrated and we are hammering on its head. So the head of the nail is having a wider surface, so we can apply more force on it, and the pointed part is having lesser area, so it will be easily penetrated into the wooden plank. The same thing will happen with the push pins or the drawing pins. You might have seen that it is also having a wider surface area. The head of those pins have a wider surface area, and that is why we can easily penetrate, we can easily push it into the board, or into the board like that. But if we are taking any ordinary pins whose head area is not wider, it will be not easy for us to penetrate those pins into the drawing board. Or if we are trying to penetrate the head part of the pin, then also it is going to be hurting our thumb, because the pointed part will penetrate into our thumb. So these are the things. Why does this things happen? Because the pointed part is having lesser area, and that is why that pointed part is easily pressurized, and then that easily goes and penetrates into the wooden plank or any other things. But if wider surface area will be there, then it will not be penetrating. I'll give you one simple example of camel. Now this camel's foot are very broad, and that is why it do not penetrate into the sand. You just imagine that what will happen if the legs of the or the foot of the camel are very pointed. These are going to be stuck into the sand itself, and then it is going to be very difficult for the camel to lift its leg and to move from one place to another. So just because it is having a broad foot, wider surface area is there, and that is why the legs of the camel do not penetrate into the sand, and this is how camel can walk easily into the sandy area. So because this is the relation between pressure, force and area, that pressure is equal to force upon area on which the force is applied. So pressure is directly proportional to the force but inversely proportional to the area, and the unit of pressure is Newton per meter square, because force unit is Newton and that of area is meter square, and that is why the unit of pressure is Newton per meter square. It is also known as Pascal. And the unit for pressure is a bar also. So 1 bar is equal to 10 raised to 5 Pascal, and pressure is a scalar quantity, because only the importance of the magnitude is taken, that means only there is importance of force and area, not the direction in which the pressure is applied. So that is why when the direction is not taken into consideration, we can say that pressure is a scalar quantity, and the quantities in which both the magnitude and the directions are taken into consideration, we can say that it is a vector quantity. So pressure is not a vector quantity, it is a scalar quantity, because the direction in which the pressure is applied, that is not considered. So presently we are considering only the force acting on an area in a direction perpendicular to it. Now I'll give you another example, that if you are taking a blunt knife, the blunt knife will have wider surface area as compared to the sharp knife, and that is why blunt knife will not cut the things or the fruits easily, but the sharp knife, as it is having lesser surface area, it will penetrate easily into the vegetables, and the vegetables or the fruits can be cut very finely. So this is the relation of area and pressure, and let me tell you again that force is directly proportional to pressure, and pressure is inversely proportional to area. So keep all this thing into mind.